Today we're going to look at interest rates. Warm up. You are at Applebee's with your friends and have an exceptional waiter. You decide to tip him 20%. If your bill is $14, what will you leave for the tip? So there's several ways to figure this out. A lot of people like to look at taking 10% of something. So 10% of $14 would be $1.40. So 10% would just be moving the decimal place one over. So that'd be $1.40. And then if you do $1.40 plus $1.40, that would be 20%. So the tip would be $2.80. So again, many ways to calculate 20% of $14. Another way is you can change 20% to a decimal. So to change a percent to a decimal, you can take 20 divided by 100, or it's just the same as moving the decimal place over twice. So 20% is 0.20. In math, of means times. So if I want 20% of 14, I can take 0.2 times 14, and we can calculate what 20% of 14 is. So in our calculator, let me pop that up. So I could do 0.20 or 0.2 times 14, and we'll get the 280 like we calculated before. All right. Can you figure out what you owe total in one step versus two? So what I mean by two steps is here we calculate the interest, but then we need the total amount that we pay. And we know that $14 is the total amount. So if I take $14 plus the 280, the total amount that we owe is $16.80. So that's the amount that we owe for the food plus the tip. We would pay $16.80. So this question, how can you figure out what you owe total in one step versus two, means how can you figure out that $16.80 in one step versus calculating the tip and then adding it to your total. So here is the calculation for that. If you do your $14 plus, and remember this is the tip, this was that 280, the 20% times 14. Instead of doing it in two steps, one way we can do that is we can factor out the price. Factor means what's a number that we could divide out of both of these terms. And the first term is 14, and the second term is the 0.2 times the 14. And if you notice, they both have a 14 in them. So let's factor that out. Let's divide it out. Factor means divide it out. And imagine if we divide each of these by 14, what's left? Well, we know 14 divided by 14 is 1. So we have 1. And then here, if we have 0.2 times 14 divided by 14, again, the 14s cancel, and we have the 0.2. So again, all I'm doing is taking this equation to calculate the total amount that we owe, dividing each by 14. It's like undoing the distributive property, and we get this simplified expression 14 times 1 plus 0.2. And if we type that into our calculator, and if I add the 1 plus 0.2, that's the same as 14 times 1.2, we will get our 1680. So essentially what we're doing is we're taking the amount that we owe, 14, and we're taking 100% of the amount that we owe, the 14, and we're adding to that 20% of the 14. So the 1 plus 14 times 1.2, the 1.2 stands for taking 100% of what we owe and adding in the 20% tip. So again, the 1 is the 100% that we owe plus the 0.2, and that is the tip that we owe. So there's the one-step calculation. Let's see how it works in other problems. You go out to dinner at a fancy restaurant with your family, and the bill is for $68. Your parents want to leave an 18% tip for the waiter. How much do you pay in total? Well, we owe $68. We owe 100% of the $68 plus our tip. I'm going to change the 18 to a decimal, so 0.18. And so here's the one-step equation. It'd be 68 times 1 plus 0.18. If you want to make it even quicker, it's 16 times 1.18, and that will give us our answer. So whatever we type in, this 1.18 times the 68, that'll be the $68 plus the tip. It kind of builds that in. So let me multiply that for us. So we would have, let's clear this, 68, and I'm just using the Desmos scientific calculator because hopefully you have that, times, I guess I could use parentheses just to make it look like what we had. So times 1.18, and So total, your parents will leave $80.24. So that is the tip plus the amount of the meal. So 80.24, let's write that in. So again, the 1 is 100% of what you owe, plus it adds in the tip the 18% of the 68. So let's do problem number 2. Pizzas at Blaze are on sale for 30% off. The pizzas usually cost $8.50. How much does it cost now? All right, so whenever there's a sale, like if it's 30% off, I always think about, all right, what percent am I paying? And if it's 30% off, you're still paying 70% of the total cost. And so to get that, we have again our $8.50. And we have 100% of the cost, but it's 30% off, so 1 minus 0.3. And what we get is $8.50 times 0.70. So what this means is we're taking 70% of, again, of means times $8.50. And that'll be the sale cost. We're paying 70% of $8.50. All right, let's type that in. Let's clear this. All right, so we have $8.50, the price of the pizza, times 70%, so 0.7 or 0.70. And as you can see, the pizza is now $5.95 if we're paying 70% of $8.50. So our pizza is $5.95. Great deal for one of their pizzas. Okay, let's try number 3. You purchased the iPhone 11 for $699 and put all that money on a credit card. Your credit card charges you a percentage of the balance each year in exchange for allowing you to borrow money from them. It's called the annual percentage rate, APR. Your APR is 12%. So what that means is if you put money on a credit card and the credit card company lets you borrow that money, you're paying 12% interest on the amount that you still owe. So if you can't pay them back right away, they will charge you 12% per year on what you don't pay back. And that's how they make their money. So A, it says if you don't make any payments this year, assuming there's no late fees, how much will you owe total to the credit card company at the end of 1 year? So again, we owe $699. So we owe 100% of that. So there's the 1 plus the 12% interest. So this is if the credit card pays the phone. Pays the $699 for the phone, we can't pay them back. So we still owe them $699 plus the 12% interest. So if we type that in our calculator, it'll look something like this: $699 times 1.12. And let's type that in. So $699 times 1.12. And if you see what it equals, we owe now not only $699 for the phone, but the interest. So total, we owe $782.88. $782. So that includes the price of the phone that we still have to pay back plus the interest. So credit card companies really make money off of you if you can't pay them back right away. Now let's say that you bought that phone $699 and you paid them off right away in the first month, then you don't owe any extra money to the credit card company. So if you can make 100% of your monthly payments, like if you can pay off your credit card bill every month, then the credit card company doesn't make any money off of you. It's when people cannot pay what they owe per month, and then the credit card company charges interest on what those people still owe, that's how they make their money. All right, so B, it says, if you continue to not make any payments, so you're not paying the credit card company back, how much will you owe at the end of 2 years? So now we still owe the $699 for the phone plus interest for 2 years. So what we're going to do is we're going to take our $699 and we owe the 12% interest off 1 year plus the next year. So another way to write this is our $699 times 1.12 to the second power, because again, we see we owe the interest twice. So it's to the second power. There's the exponent. This is an exponential function. The exponential function is in that formula that we've been looking at. So A is your starting value, your interest rate for time, however many years. So you can see this is now in our exponential function form. And if we type that in, here's what it looks like. So let's clear this. So $699, we owe the 12% interest, and then AB, so the button next to the x squared button, there's to the power of, and it's for 2 years. Oh, I guess I could have pressed the squared button. All right, there it is. We now owe the $876.83. So again, about $700 goes back to paying your phone, but the credit card company has made almost $200 off of you because you have not paid them back. All right, so $876.83. Let's write that down. So you owe the credit card company $876.83. So again, $699 of that will go towards paying back your phone, but the rest goes to the credit card company because you owed them and didn't pay them back. If you continue to not make any payments, how much will you owe at the end of 4 years? Okay, so again, we're looking at things in this form where we have the starting value, we have your interest rate, and then T for time. Again, if I write it out, here's what it looks like. You owe the $699, the 12% interest for 4 years. But the quicker way to write that, of course, is with the exponent. So it's $699 times 1.12 to the 4th power. All right, I bet it's going to be a lot of money. It's exponential growth. So let's type that in. Let's clear this. All right, so we have $699, 1.12 interest, AB, so to get to the power of, it's 4 years, and now look at what you owe, $1,099.89. Again, $699, it goes towards the phone, but the rest is what your credit card company makes off of you. So it's like $300, almost $400 they're making off of you for not paying your monthly bills. All right, so $199.80, let's write that. Okay, so we owe $1099.89. That's a lot of money the credit card company's making off of you. So then it says, how long will it be until you owe $1,400 on the credit card? All right, it's a lot of money to owe on that credit card. How long will that take? So now we know the amount, $1,400. The starting amount was $699. It's growing at 12% per year. We want T. And again, we don't know how to solve for T if that's the exponent. We don't know the inverse of that yet, which we will learn later on this chapter. So this is a guess and check problem. So one way to do this is you could just keep typing in years here until both sides equal 1,400. I like to make the numbers a little bit smaller, so algebraically I can divide each side by 699. And that makes my numbers a little bit smaller, so let me type that in. So 1,400 divided by 699, it's about 2.002. So I'll write that down. So here's what we're looking at here. We want to know when 2.002 equals 1.12 to the T power. So now I'm going to use guess and check. I'm just going to type in years here so that on the right-hand side of the equation, I want 2.002. I want to see how close I can get so that the right-hand side is also 2.002. We know that it's going to be more than 4 years because 4 years was only $10.99. So I'll start with 5 years and see what that looks like. All right, so I'm going to type in 1.12 to the power of 5. The goal is 2.002. That's too small. Let's try 6 years. Whoops, I did 65. That is too much. All right, 6 years. Okay, we're getting closer. 7 years. Okay, so it's between 6 and 7 years. Okay, that's pretty close. And I want 0.002, so how about... So it's 6.1 something. I mean, this is pretty close. I'll just say 6.19 years. That's pretty close to that. Is 8 closer? Yeah, 8, 7. Oh, this is even closer, right? All right, so about 6.16 years. We'll say that, 6.16 years. That's pretty close. So about, also I should say T equals about 6.16 years for that total to be 1,400. Okay, and we can test that out too. So if I do if I do the original equation, 699 times 1.12 to the power of not 2, 6.16, we can see that's pretty close to $1,400. Okay, let's move on to our next formula for this chapter. It says when calculating the annual interest rate, you saw that 1 there. It's 1 plus or minus the rate. So when we're doubling something, we know that if we're doubling something, it's like y equals our starting value 2 to the t. If we're tripling it, it's times 3 to the t. So this is your interest rate. When your interest rate's a decimal, you're going to change it to a percent, and you're going to either add it if it's increasing, so add it to 1 if it's increasing per year, or subtract it from 1 if it's decreasing per year. So those are the steps. So let's write what each of these stands for. So A is your amount after t years. P is called your principal or your starting value. Oh, that kind of froze on me there. Give it a minute to catch up. Oh, there we go. R is your rate as a decimal. So either divide by 100 or move the decimal to the left twice. So R will be your interest rate as a decimal. And T is time, typically in years, but it could be different. So time. Okay, so let's practice using this new formula, which is very similar to the regular exponential growth formula. The only difference is you change your interest to a decimal and either add or subtract from 1, depending on the situation, or is it increasing or decreasing. So example 1, you have $250 and you put it into an account that gives you 4% annual interest. So here you're gaining money. Your friend has $375 and finds an account that gives her 1.5% annual interest. Who will have more money in their account after 5 years? All right, so you're starting with less, but you're making more per year. Your friend is starting with more, but they're making less per year. So again, we're making money. Let's write our two equations. Let's start with ours. So we're starting with 250, and your money's increasing. So 1 plus, you want to change 4% to a decimal. So either divide by 100 or move the decimal over twice. So that's 1, it'll be 0.04. And then we want for 5 years, so we'll put the time here. Okay, another way to write this is 250 times 1.04 to the 5th power. Okay, your friend starts with $375. And again, they're earning interest, so it's 1 plus. And they're earning interest at 1.5%. Again, if you divide that by 100, it's 0.015. So we'll put that right here, 0.015. And again, to the 5th power. Again, you can add the 1 to the decimal. This would be a little bit faster to type into your calculator. All right, so let's type those in and let's calculate who has more after 5 years. So I'm just going to use my calculator here. Okay, so you have, after 5 years, I've just typed this in, $304.16. Not bad. You've made like $54 interest. Not bad. All right, let me type in your friend. So 375, 1.015 to the power of 5 years. Okay. All right, your friend. Should change colors. So your friend has $403.98. So your friend still has more. Even though the interest rate is less, since they started out with more, they still have more at that point. We could try to figure out like when do they have the same amount, and we'll be taking a look at that later. Oops. All right, let's try just a few more examples, and then I'll have you try this in your packet on your own. Example 2, you came into a large $15,000 inheritance from a relative who unfortunately just passed away. You will be allowed to access that money when you're 21. All right, so I should underline the important information. You are able to find an account to place it in that gives you 1.5% annual interest. How much will the money be in the account when you are able to access the money? All right, so this will depend on how old you are, right? So let's just start writing our equation. So we start with $15,000. Our money is increasing at 1.5%. So if I divide 1.5% by 100, I get 0.015. And let's say you're 16. So how many years, if you're 16, how many years until you can get your money? It would be 5 years. All right, so depending on how old you are, the exponent will change. It's just how many years away are you from 21. right, so if you're 16, let's see how much money will be in your account when you can access that money. So I'm just going to type in this right here for 5 years. And at that time, you'll have $16,000 or $16,159.26. So you've made over $1,000 just on interest for leaving it in there for 5 years. All right, so again, you want your starting value, the 1 plus if it's increasing, 1 minus if it's decreasing, and then your time as the exponent. All right, let's do 2 more examples and then let you guys work on this. You owe $500 on a credit card that charges you 19% annual interest, annual percent rate on the balance that you don't pay off. How long will it take before you owe $1,000 if you don't make any payments on the card? All right, so again, the amount of money that we owe is increasing because we're not paying it off. So we want to know, when is the amount $1,000? We start with 500. The amount that we owe is increasing at 19%. We don't know time. So this is a guess and check problem. We don't know time. I will make the numbers a little bit smaller by dividing by 500. So here's what I'll be looking for. 2 equals 1.19 to the t. I'm going to type this into my calculator and look for what time gets me closest to the number 2. All right, let's type that in. All right, 1.19 to the power of, I don't know, I'm just going to pick a 6. Oh, okay, that's too much, right, because 2.83. Let's do 4. Ooh, that's pretty close. I'm going to say 4 years for our money to double, or for the amount that we owe to double. So here, the time is 4 years, and you can check that by plugging in the 4 years, and you should get very close to $1,000. All right, let's do an example where something's decreasing. We haven't done that yet. So example 4, you are giving your dog a bath and you start draining the water. You notice that the water is draining at a rate of 30% a minute. If there are 25 gallons of water in the tub, how much will be left in the tub after 5 minutes? Okay, so here we're starting with 25 gallons of water. It's decreasing. So here's an example of 1 minus because the amount's going down at 30% per minute. And we want to know how much is in the tub after 5 minutes. So you can either write it like that. The other way to write this is you can subtract the 1 minus the 30%. It's like $1 minus 30 cents. So you could put the 0.7 here because $1 minus 30 cents is 70 cents. And you can type that in. All right, so I'm going to type in. Okay, so after 5 minutes, there is 4.2 gallons of water left in the tub. About how long will it take for the tub to have less than a gallon of water in it? So I'll just put 1 gallon here, and we would say after this time. I'm just going to put the 0.7 here. All right, so guess and check. I'm just going to divide each side by 25. Actually, this one I'll just leave. Okay, so this one I'm going to leave, and I'm going to type this in, and I want to know which time will give me the number 1 on this side. Okay, so 25.7 t. So 25.7 to the power of, I know it's going to be more than, what was the last one that we looked at? More than 5 minutes, so I know it's going to be more than 5 minutes because then we still have 4 gallons. All right, so let's do like 10 minutes. Oopsies. Okay, so 10 minutes. Okay, here I have less than a gallon. Let's go to 9 minutes. Okay, so here it is. 9 minutes gives me 1 gallon. So we can say after 9 minutes, we'll have less than 1 gallon. So here, t is about 9 minutes. So we can say after 9 minutes, we'll have less than a gallon. All right, so your assignment today is to read through the problems. Can you figure out the starting value? Can you figure out if we're adding or subtracting? Can you solve for if I give you a time or if I give you an amount? So your assignment is to complete the next 2 pages. It looks like 25 and 26. I'll put the answer key on Google Classroom so you can check your answer. So do pages 25 and 26 for tomorrow. Interest rates.